Hello and welcome. This is Dr. Sonu Kumar Gupta, and here I'm explaining about Lami's theorem. So that is called also equilibrium of three. That you can say equilibrium of three force system, that is also called Lami's theorem. So let us see the statement of the Lami's theorem. Lami's theorem Lami's theorem states that Lami's theorem states that when three forces acting at when three forces acting at a point are in equilibrium, then each force is proportional to then each force is proportional to the sine of angle between other two forces. So how to derive? Let us see the derivation of Lami's theorem. So this was the statement. Now derivations. So here we can say that three forces acting at a point. So that is the coplanar forces. That also concurrent forces. Coplanar and concurrent. So from this point forces are passing from the single point. Three forces that is passing F1, F2 and F3. In that, here alpha, that is the angle made between F1 and F2, beta, angle made between F1 and F3, and gamma, angle made between F2 and F1. Then how to prove it? Let us first clarify the angles between these three. So for this again we will draw it or try to make one parallelogram by using this same forces. So this is forces as we are representing here. This is F1, F2 and F3. By using F1 and F2 we'll make one parallelogram. So we'll draw a parallel line to F1 and one parallel line to F2. So we'll give a name also. This is origin O and A, B. This is F3 is given. So as this is given, alpha, this is a beta, and this is a gamma. Here we'll draw one. This F3 will extend to make a diagonal of this parallelogram. So as this diagonal is equal to F3, because these forces are under equilibrium, so here that condition need to follow. So this will be equal to f3 as this angle is given alpha. So this remaining angle, because while we are considering this line, if you are considering, so at this point it will be 180 degree. So already alpha is given, so what is the remaining value? That will be 180 minus alpha, degree minus alpha, and this value is similarly 180 degree minus beta. As this makes gamma, this angle is gamma, and what we'll do, we'll extend the line of force F1. So these two lines F2 and this parallel lines, both are parallels. So accordingly this angle also will be gamma. So as we have this is a line making angle 180 degree, gamma is given, so that remaining angle will be 180 degree minus gamma. Again we'll prove it how we are getting 180 minus gamma. So this is C point. So let us see angle ACO in this angle ACO, that will be equal to, as 180 minus alpha, this angle will be 180 minus alpha, so this angle also will be 180 minus alpha. So here writing ACO 180 minus alpha, 180 degree minus alpha. Then angle COA, that will be equal to degree minus beta, and angle OAC is equal to 180 degree, because if you consider one triangle, this triangle, so summation of three angles will be 180 degree. So here you can write 180 degree minus 180 minus alpha, this angle, this also will be 180 minus alpha. So three angles we have, 180 minus 180 degree minus alpha, and minus 180 degree minus beta. So while we will simplify it, 1 degree minus 180 plus alpha minus 180 degree plus beta. So here these two will be cancelled, so alpha plus beta minus 180 degree. So alpha plus beta, what we will write here? Alpha plus beta, as we have angle this alpha plus beta, and internal angles, included angles is gamma, so we can write here, instead of writing alpha plus beta, we can write 360 degree minus gamma minus 180 degree. So that if you simplify, it will be 180 degree minus gamma. So angle we have here. So now we'll apply the sine rule. Now apply sine rule. So when you will apply the sine rules, what we can write here? We can write OA divided by sine angle ACO. OA by, it means this side and this angle will take. So accordingly we are writing here is equal to, if we are applying a sine rule, OA by sine ACO, then CA, one different side we are taking, CA, that is divided by sine COA is equal to OC divided by sine angle OAC. Again we can write this at OA by sine 180 minus alpha. This angle ACO will be 180 minus alpha, that is given in the diagram. So that we can see here, that is equal to CA by sine 180 degree minus beta is equal to OC divided by sine 180 degree minus gamma. So this is written. So what next? What is OA? OA, here it is showing OA, that is F1. Then CA, that will be the CA that is equal to F2, because this two line is parallel. And OC, this line, that will be the equal to the F3. So accordingly we will represent this F1 by sine 180 degree minus alpha, F2 by sine minus beta, F3 by sine 180 degree minus gamma, or we can write here F1 by sine alpha is equal to F2 by sine beta is equal to F3 by sine gamma. So this is Lami's theorem, what we are trying to prove. So this is proven now, and this will be the final expression by using the Lami's theorem, by doing the expressions for 3-4 systems. So this is only applicable when there is only 3 forces acting at a point, means that is a coplanar and concurrent forces. So for that case we'll apply this expressions. So wherever we have numerical problems having 3 forces, so in that case we can apply this. Thank you.